Acrylic is a pretty common plastic that people machine, and since I've already done a video about it in reference to the Nomad, I think it's only fair I do the same for the Shapeoko. By and large, you can use the exact same settings on either machine at 10,000 RPM, but two things on the Shapeoko allow us to go significantly faster in acrylic: speed and power. More RPM and more torque lets us take more aggressive cuts on the Shapeoko, and this is what that looks like. Starting off small with a 16th inch 2-flute square end mill, for pocketing I like 18,000 RPM, 72 inches per minute feed rates, a 0.045 inch depth of cut, and a 1/32 inch step over. For an adaptive toolpath, and this is a conservative set of parameters, I'd start at 18,000 RPM, 90 inches per minute, a 16th inch depth of cut, and a 0.01 inch optimal load. There is a ton of room to improve on this recipe, but as I've been told many times in college, finding the limits is an exercise left to you. In a slotting application or full width of cut contour, I like to back off a little because of the increased wall contact and compromised chip evacuation. 18,000 RPM, 54 inches per minute, and a 1/32 inch depth of cut. Next up, with an 1/8 inch end mill for pocketing, I would start at 18,000 RPM, 72 inches per minute, a 0.08 inch depth of cut, and a 50% step over. An adaptive toolpath might go something like 18,000 RPM, 108 inches per minute, an 1/8 inch depth of cut, and a 0.013 inch optimal load. Again, this is probably quite conservative, but it is supposed to be a safe place to start. For 2D contours, 18,000 RPM, 50 inches per minute, and a 1/16 of an inch depth of cut. And lastly, for a 1/4 inch end mill like our 201 cutter, for pocketing, 10,000 RPM, 75 inches per minute, a 1/16 of an inch depth of cut, and an 1/8 inch step over. Adaptive clearing, 10,000 RPM, 105 inches per minute, a 0.15 inch depth of cut, and a 1/16 inch optimal load. And last but not least, for contouring, 10,000 RPM, 75 inches per minute, and a 0.055 inch depth of cut. Okay, if you're still awake, you might have caught a few discrepancies here, like why is my depth of cut so conservative with the 1/4 inch end mill as compared to the 1/8 inch end mill? It really boils down to the fact that I'm a coward, but hear me out. If you're using cam strategies on the more basic side that start by jamming the end mill straight into material like Carbide Create does, you need to be careful with hard, melty plastics. Direct plunging moves are risky here because we need to balance two factors. The first is tool pressure. If you'll recall from basic physics that pressure is force over area, the larger your end mill is, the more force you need to apply in order to get the face of that cutter to pierce into your stock material. We can stab an 1/8 inch end mill into acrylic really easily, but pressing a 1/4 inch end mill into acrylic too fast can cause you to lose steps on the Z-axis. The HDZ can handle a lot more force, but I'm scaling this recipe back for our stock Shapeoko 3 users. For larger tools, I would recommend a plunge feed rate of no more than 10 to 12 inches per minute. That works out to 1 thou per revolution of the cutter. Now that's all well and good, but as soon as your end mill touches acrylic, you've started a timer. You're going to quickly build up heat through friction and risk melting the acrylic, which is highly undesirable. The sooner you can start cutting and move away from your entry point, the better. And that's why I personally prefer keeping these cuts slightly shallower and faster, especially because our 1/4 inch cutter is running a little hot. Most recommendations for acrylic that I see target about 600 surface feet per minute. 10,000 RPM puts the edge of our 201 end mill at just north of 650 SFM. If you're using Fusion or some other cam package where you can ramp or helix into your material, you can definitely get away with deeper cuts. But for basic toolpaths that plunge straight into stock, I find that 10 inch per minute plunges combined with depths of cut of less than a 1/16 of an inch provide the greatest reliability, so that's where I recommend that most people start. I hope these cutting recipes help those of you who are looking to get started with acrylic. If you purchase more specialized end mills for machining plastics, keep in mind that the recommended cutting parameters will be a little different. Good luck and have fun machining, folks.